The Kuiper Belt or Edgeworth. Kuiper is an outer region of the solar system that extends from the orbit of the planet Neptune, about 30 astronomical units away from the Sun, up to 50 astronomical units from the Sun. Its overall shape is somewhat reminiscent of a donut. It takes its name from the astronomers Gerard Kuiper and Kenneth Edgeworth, who in a 1951 article hypothesized that the presence of objects beyond the orbit of Neptune, later known as trans-Neptunian objects, or TNO for short. Unlike the main belt between the orbits of Mars and Jupiter, essentially composed of rocky bodies, the Kuiper belt is composed of small icy bodies, mainly water ice, ammonia, and methane, whose orbits are arranged on the plane of the ecliptic, which is the same plane on which the orbits of the planet also lies. The presence of Neptune has a profound effect on the structure of the Kuiper belt due to orbital resonances. An orbital resonance occurs when two orbiting bodies have periods of revolution such that the relationship can be expressed in fractions of small whole numbers. For example, Pluto and Neptune are in a 2 to 3 orbital resonance. This means that every 3 revolutions of Neptune around the Sun, Pluto takes 2. Over a period of time comparable to the age of the solar system, it can happen that Neptune's gravity destabilizes the orbit of objects in orbital resonance, sending them into the inner solar system, or pushing them outwards towards interstellar space. The gravitational influence of Neptune produces pronounced gaps in our current structure of the belt, that is, in areas in which there are very few or no objects. These are precisely zones of gravitational instability produced by orbital resonances. Over 2,000 Kuiper belt objects, or KBOs, have been discovered in the belt, and it is thought that there may be well over 100,000 with a diameter greater than 100 kilometers, and that the total mass of all objects in the Kuiper belt could be a tenth or even a 100th of the Earth's mass. In total, there could be millions of celestial bodies in the Kuiper belt. Kuiper belt objects can be roughly divided into classical and resonant. In the first case, or classical Kuiper belt, the objects can keep their orbits unchanged over time. Here we find about 2/3 of the KBOs observed to date. 1992, QB1, the first modern KBO discovered. Pluto and Charon apart is considered the prototype of this group, from which it derives the term Cubuenos, a term that indicates the classical KBOs, and which is the phonetic translation of the English acronym QB1Os. According to the IAU guideline, the name to be given to classical KBOs is that of mythological beings associated with creation. The classical KBOs are mainly concentrated in 2 areas with orbital resonance with Neptune 2 to 3 and 1 to 2, between 42 and 48 astronomical units from the Sun, where the gravitational influence of Neptune is negligible. The classical Kuiper belt appears to be composed of 2 different populations. The first, known as the dynamically cold population, is composed of objects with orbits very similar to those of the planets, so almost circular, with an orbital eccentricity less than 0.1, and orbital inclinations not exceeding 10 degrees. The second, the dynamically hot population, has much more inclined orbits than that of the ecliptic, up to 30 degrees. The 2 populations were named in this way not because of a difference in temperature, but because of the analogy with the particles of gas, which increase their relative velocity with temperature. The hot population is believed to have formed near Jupiter and been expelled by the movements and gravitational interactions of the gas giants. Furthermore, it is believed that the cold population formed more or less in its present position, although it may have been flung outwards later, during the migration of Neptune, described by the Nice model, which owes its name to the Observatoire de la Côte d'Azur of Nice, where it was formulated. The Nice model is a physical model that simulates the dynamic evolution of the solar system in the phases immediately following its formation, and according to it, Neptune and Uranus were originally much closer to the Sun than they are today. Would you have liked to see this important moment in the evolution of a solar system? Write it down in the comments below. As for the resonant Kuiper belt objects, they're in orbital resonance with Neptune. Objects in 2 to 3 resonance with Neptune have a semi-major axis of about 39.4 AU, and about 200 of this type are known, including Pluto and its moons, as well as prototypes of the members of this class known as Plutinos. Plutinos have high orbital eccentricities, suggesting that they didn't originate in their current locations, but were hurled out to the older solar system by the migration of Neptune. IAU guidelines dictate that all Pluteans must, like Pluto, be named after deities associated with the underworld. The 1 to 2 orbital resonance zone, whose objects complete one orbit while Neptune makes two, and have half-axes greater than 47.7 AU, is sparsely populated. Members of this class are known as Twatini. There are other resonances with ratios 3 to 4, 3 to 5, 4 to 7, and 2 to 5. Neptune also has a number of Trojan asteroids occupying its Lagrangian points L4 and L5. These are often in 1-to-1 resonance with Neptune and have generally stable orbits. The largest body in the Kuiper belt is Pluto, and the most massive is the dwarf planet Eris, discovered in 2005, although some scientists considered Eris to be part of the diffuse disk rather than the Kuiper belt. Since the year 2000, other objects of considerable size have been found. 50,000 Quoar, discovered in 2002, half the size of Pluto and larger than Ceres, the largest of the traditional asteroids. The exact classification of this object is unclear because there's probably very different from the innermost of asteroids. Some satellites of the planets of the solar system appear to come from the Kuiper belt, such as Triton, the largest of Neptune's moons, and the Saturnian moon Phoebe. It is believed that short-period comets, that is, those that take less than 200 years to travel their orbit around the Sun, come from the Kuiper belt. In addition to the classic and resonant Kuiper belt objects, the diffuse disk should also be mentioned, a sparsely populated region whose innermost part overlaps the Kuiper belt and extends up to 100 AU from the Sun and beyond. Unlike what happens for the objects of the innermost Kuiper belt, and that we have spoken about now, the objects of the diffuse disk travel in a very elliptical orbit and often very inclined with respect to their ecliptic. Most models of the solar system's formation shows that both KBOs and disk objects were part of a belt of primordial comets, and that subsequent gravitational interactions, particularly with Neptune, sent these objects outward, some in stable orbits, KBOs, and others in unstable orbits, forming the diffuse disk. Among the objects of the Kuiper belt, even if it present mainly in its outermost part, there are also detached objects whose orbit is almost entirely included between the 40 and 50 astronomical units away from the Sun. Given their gigantic distance from Neptune, it is unlikely that these objects will suffer the gravitational perturbations. An example of a detached Kuiper belt object is Sedna, whose orbit has perihelion at 76 astronomical units from the Sun and an aphelion about 1200 astronomical units from our star. The Centauri asteroids deserve a separate mention. Their orbit extends between Jupiter and Neptune, from which they suffer the intense gravitational attraction. Many of them, due to these gravitational perturbations, end up being ejected from the solar system or pushed towards the innermost areas of the solar system, where they become comets or crash into the Sun and planets. The first probe that explored a celestial body in the Kuiper belt was the New Horizons probe. Launched on January 19, 2006 from the Cape Canaveral base on July 14, 2015, it flew by Pluto. Would you like to see this dwarf planet up closely? Write it down in the comments below. The primary objective was to study the geology and morphology of the dwarf planet Pluto and its satellite Charon, create a map of the surface of the two celestial bodies, and analyze their atmosphere. Other objectives were the study of the atmosphere of the two celestial bodies over time, the high-resolution analysis of some areas of Pluto and Charon, the analysis of the ionosphere and charged particles, the search for the atmosphere around Charon, the study of 4 minor satellites, Styx, Nix, Kiribos, and Hydra, and the search for any unknown satellites or rings. Given the good condition of the probe after the primary mission, NASA technicians decided to make it continue the journey in the Kuiper belt to send data on the belt to Earth. On January 1st of 2019, the spacecraft crossed the orbit of asteroid 486958 Arrokoth, also known as Ultima Thule, in the Kuiper belt, flying over it at a minimum distance of about 3,500 kilometers. Discovered on June 26, 2014 by the Hubble Space Telescope, Arrokoth is a primordial body of the solar system 36 kilometers long and composed of 2 planetesimals of 21 and 15 kilometers of diameter called Ultima and Thule, respectively the lower and upper lobe, united along their main axes at the level of the neck, hence the classification of binary asteroid in contact. Precisely the bilobed shape in the days following the overflight of the New Horizon triggered the Toto nicknames all over the world. Some called it a snowman, some peanut, and etc. But apart from the shape, what is most surprising about Arrokoth is the silhouette of the two lobes, surprisingly flat. There is no other celestial body that has a similar shape. According to a study published on Nature Astronomy, it is likely that Arrokoth initially had an ordinarily chubby shape formed 4.6 billion years ago by the condensation of particles from the same primordial nebula that formed the other celestial bodies of the solar system. The particles of this cloud would subsequently agglomerate to form increasingly larger bodies, two of which, one spherically and one oblate, that is, pot-bellied at the equator. Colliding would have produced the asteroid. The flattened shape would eventually be acquired over millions of years by sublimation in the condensed grains, a process that began when the nebula in the region of space thinned out, allowing the sun's rays to increase the cold temperatures present and to sublimate Arrokoth. Its strange shape would therefore be the natural result of a process of mass loss due to the degassing of the volatile compounds that constituted it, to which, however, a favorable combination of intrinsic characteristics of the objects, such as the particular axial inclination and the small orbital eccentricity of the celestial body, should be added, resulting in an almost symmetrical erosion between the northern and southern hemispheres. These characteristics explain why the celestial body is flattened out and not shortened or shrunk, as Arrokoth's axis of rotation is almost parallel to the orbital plane. During its 298 years of orbit around the Sun, one polar region of Arrokoth faces our star for almost half the time, while the other faces towards the opposite side. The regions at the equator and in the lower latitudes are dominated by the diurnal variations throughout the year. With the speed of 58,536 kilometers per hour, or 16,260 meters a second, reached when the third stage was turned off. New Horizons is the man-made object that has reached the fastest speed in leaving the Earth. The probe contains part of the ashes of Clyde Tombaugh, the astronomer who discovered Pluto in 1930, a CD-ROM with the names of 434,000 people who signed up for the project, 2 coins, 2 US flags, and a 1991 postage stamp which reads, "Pluto, not yet explored." If you haven't already done it, drop a line below and let us know what you think.